One of the big questions I get about flat Earth is, for one, how does the flat Earth map work? But one of the big questions I get is, how do the seasons work? And also another question I get is, how come there is a 24-hour sun in the North Pole in the summertime and 24 hours of darkness in the wintertime? Well, it's really, really simple. Now, first of all, let me run over this with you really, really quick because I got to get to bed and I don't have a whole lot of time. So I'm going to show you the map, which is patented on November the 15th, 1892. This is the version I have on my wall, but I took it off tonight so I can show you this really, really quick. As you can see, it's 10/4/1892. Okay, first of all, before I show you how this map works, what I want you to notice is over here to the right, you have the winter solstice, which starts on December 21st. Now, this right here in the center is the North Pole. Now, this little circle that you see right here with this illumination around it, that's the sun. Now, in the wintertime, the sun is out here. It's on its outer circuit, making its circuit around the Earth. It's further out towards the ice wall. Okay. Now, in the summertime, which would be your summer solstice, which is on here called the June solstice, and it explains to you pretty much how that works. Okay. And I don't have time to show you. If you want to get really, really good detail, just order the map. But anyways, notice how the sun here is closer to the North Pole, making a smaller circle than it does in the winter solstice, which is out here, which means it makes a big circle. Now, let me explain to you how that works. Okay, I'm going to turn the light off on this phone for just a second so you can see how this works. Okay, here we are. I've gotten it dark like it would appear in real life. Now, we're going to use this flashlight as the sun source. Now, in the wintertime, the sun is further out, which means, okay, here's the ice wall that surrounds the Earth. Let me get you guys familiar with this really, really quick because I don't have a whole lot of time. Now, here's North America. Here's South America, here's Africa, here's third world countries, and here's Australia. Now, in the wintertime, the sun is out here making its circuit around the Earth. And it never changes up its speed. It's always going the same speed. But being that it's further out, it takes a longer time for it to come back around. That's why in the wintertime, your nights are longer than your days, because it takes the sun a longer amount of time to get all the way back around. Now, as the months go by and it starts to get into spring, well, guess what the sun does? It starts to move back in on its circuit. So that's why, notice when the sun starts to move in, see, say this is the daytime in America, which is right here in the summertime. Well, you have daytime there. Well, check this out. In the spring, the sun starts to move closer in. So guess what starts happening to this continent and this continent and this continent? Well, it starts to get warmer because the sun's moving in. That would be your spring. So now, let me fast forward really quick. In the summertime, the sun is all the way in here. Now, that's why your days are longer, because it doesn't take the sun very long to get back around to you. So the nights are really short and the days are longer. Doesn't mean the sun's moving faster. It's just on a shorter circuit. Doesn't take long to make that circle when it's making a small circle. You guys see what I'm saying? So in between the winter solstice and the summer solstice, you have this in-between time, which is right in here. Well, in the summertime, it's really, really hot here in America. Okay, so in the fall, well, the sun starts to move back out. So this in-between right here, this is your spring and fall. This in-between time when the sun starts to move back out, guess what? It starts to get colder because it's moving further away from you. Now, notice everybody's like, oh, well, the southern countries are always hot. Well, it's really, really simple. You got South America, you got Africa, and you got Australia, and it's usually always hot in those areas. You know why? Because they're usually always under the sun as it's moving back and forward on its yearly circuit around. Now, it's really, really simple, and that's how your seasons work. In the summertime, it's a small circle, just like this right here. That's why your days are longer and your nights are shorter. Well, when the sun moves back out, notice how your days start getting shorter. That's because the sun's starting to make a bigger circle. And then in the wintertime, your nights are really, really long and your days are short because it takes the sun a long time to bring its light back around and its heat back around. But its heat is way out here, and that's why it's cold here in the wintertime. But say in South America or Africa, it's not really cold in any of those months because the sun is always over them, no matter if it's here or no matter if it's here. It's always over these countries. Now, your midnight sun, which is a 24-hour sun, and I think that for 187 days, which is a little over 4 months, which makes sense. You know, a summertime is about 3 months, a little over 3 months long. So as it fades back out, well, now, here's my point. If you're in the North Pole has 187 days of daylight, okay? Well, it's really, really simple. Look at the North Pole. This is the North Pole. In the summertime, the sun's on its short circuit, so guess what? It stays lit up the whole time. Even though the other countries over here are dark and the United States is lit up in the daytime, these countries are dark. Well, guess what's still lit up? The North Pole, the Arctic. No matter where it is, its circuit is so short, it keeps it lit up the whole time. And then you have 163 days, I believe it is, of darkness in the North Pole in the wintertime to us here in the United States. So in the wintertime, guess where the sun is? It's out here. So look at the North Pole. For all those months, it has no light because the sun is out here making its circuit. It's really, really simple, guys, once you understand how to read this map. And right here, it's very, very simple. That's why it says right here, longitude and time calculator. This tells you how the months work and it tells you how the time works. Now, up here you have the morning, and over here you have noon, and right here you have evening, and right here you have midnight. So notice in Roman numerals how it goes 1 all the way over to 12, and then it starts over again, 1 all the way around to 12, because half of the earth for 12 hours is lit up. So let's say from morning all the way around here to evening. Well, over here it's midnight. That's why it says midnight there, because it's dark there. The sun is on this half of the earth, and then when it moves to this half of the earth, this half over here is dark. That's why it's numbered the way that it's numbered: morning, noon, evening, and night, midnight. That all the ancients knew this for years and years. And that's why this map, if you look at the very top, it says scientifically and practically correct as it is. Now, if you're wondering why the map says time calculator, well, it's really, really simple. For thousands and thousands of years, all the ancients used a sundial to tell the time. Okay? Now you have to remember this. They even taught you this in school, that the sundial was used to tell time. Now if we use a ball, a spinning ball, and the sun, it doesn't work. But I'm going to show you how this works. Check this out. It's really, really simple. Okay? Hold on just a second. Okay, we're going to use this pencil right in the center of the earth at the North Pole as our sundial. And I'm going to show you that why this says time calculator. Now, let's say this is the sun, and remember the sun revolves around the earth clockwise. So here's our shadow from the sundial in the center of the earth. Now, as the sun makes its rotation, watch what the sundial does. What's it do? It tells the time: 3 o'clock, 4 o'clock, 5 o'clock, 6 o'clock, 7 o'clock, 8 o'clock, 9 o'clock, 10 o'clock, 11 o'clock, 12 o'clock. As the sun makes its circuit, that's how the sundial works. You see where I'm coming from? Now when it's dark over on that side of the earth, It's light over here. You see, the sun has to make that circuit to make that sundial work. It's really, really, really simple, guys. Really simple. That's the only way it can work. The sundial does not work on a spinning ball. So if it doesn't work on a spinning ball, then that should tell you that the Earth's flat. Either the Earth is not flat, and for 5,000 years people were telling time the wrong way. And I don't think that that's very possible at all. Thanks for watching, guys.